Hi everybody, Dr. Pingle here. We are still talking about hotspot analysis in ArcGIS, and I've loaded some of the tornado initial point data sets. So these are the starting points of tornadoes that have occurred in the United States since I think about the mid 1950s. So you can see that we've got quite a density here. We typically would use some kind of aggregation tool like kernel density analysis to get a handle on all of these overlapping dots. Today what I wanted to do was show how you can use optimized hotspot analysis to similarly get a handle on this data set. So we're going to use our tornado initial point as our inputs. Our output feature we'll just use as tornadoes. Now, the analysis field could be something that you would want to apply a certain weight to. If each observation had a number associated with it, so a common thing would be like maybe a population field, you could use that. In this case, each tornado is its own entity, and they don't need to be weighted. So I'm going to leave this blank. What's different about this tool when applied to points versus polygons is that we're going to need to aggregate these things. Now, there are a number of different aggregation methods in ArcGIS, and so one method is a fishnet grid, another one is a hexagon grid, and you can aggregate these things to existing polygons. So if you wanted to aggregate them to state boundaries or county boundaries, you could do that as well. In our case, so a fishnet would just be a regular rectangular grid. Just because this is kind of a nice tool, we're going to use a hexagon grid to visualize this, which is often looks quite nice and adds a little bit of extra flair to your output map. It also is nice because the hexagon way of gridding space distorts space a little bit less, so you don't get these kind of strange corner effects. It's a little bit more complicated to count them. Maybe it takes a little bit longer, but the output is generally a little bit more reliable and generally much better looking. So we're just going to go ahead and run this. Now these tools can take a little time. There are a number of steps kind of going on in the background. So first it has to generate this aggregation method. So it's going in the background and it's generating a hexagon grid. It's figuring out how many points are in each hexagon. And then it proceeds to kind of run the grid in the way that we saw in the previous video. So it's a multi-step process, and in fact this tool is kind of combining a number of different things that you could already do in Arc. And so if you don't know how to do the aggregation to fishnets, that's a useful thing to know kind of in its own right. So this tool is almost done running. And here we are. All right, so we have our tornadoes still over the top, so we'll get rid of those just so we can see what's going on. Here we go. And this would be our image of tornado hotspots and cold spots. Again, it's applying the sort of neighborhood threshold value to say, you know, is my value in my neighborhood, which is calculated automatically but has a range of, you know, a few hexagons. Is my neighborhood significantly different than the surrounding area? Is it significantly higher? Is it significantly lower? So you can see these areas that are significantly higher, kind of extending from the south through the Midwest. We can change the symbology here so you can maybe semi-transparent view to kind of peek through underneath to kind of orient yourself. You can see the Appalachians up here in the Northeast, low zones, and kind of the far northerly zone here, and most of the West is no. So Florida and kind of this area here with an interesting little patch in the middle showing up as a relative low as well. Maybe not a relative low, but not a high. So there's an application of optimized hotspot analysis to point data. You can do the same thing with line data. A very useful tool and a nice way to kind of quickly visualize your data.